Hi guys, so in this video we'll be discussing cross elasticity of demand. First of all, we'll go over its definition, then we'll discuss the formula right over here, and then we'll go over the values. So the definition of XCD, sorry. So this is known as XCD, even though it should be CED, but for some reason it's called XCD. So cross elasticity of demand evaluates the relationship between two products when the price in one of them changes. It shows the relative change in demand for one product as the price of the other rises or falls. This might not make sense, but let's have a look at the formula. I think it will make much more sense later on. So this is the formula. Percentage change in QD. QD is of the good in question. So let's say if you have like good A and B, and these two goods are related, either they are substitutes or complements. I'll explain what that means later on. Um, but we have two different goods, A and B. So let's say if this represents the QD of A, and since the denominator represents a percentage change in price of a related good over here, then this can be the change in price of B. This is what the formula means. Now moving on to the values. So we have four different categories here in total, and we'll look at the first two first, obviously. So both of these categories lie under the region of substitutes. So both of these are substitutes over here, which basically means that let's say if you have two different goods, Pepsi and Coke, just like that, those are substitutes. And if you have chicken and meat, so chicken and meat are also substitutes, but there's a difference here. So in the case of chicken and meat, they're weak substitutes. And so because of that, the value of XCD is less than 1, since they are weak substitutes. For example, let's say if you were to buy chicken, then you can't really say that meat, for a lot of people, meat is usually their preference as compared to chicken. And so if you were to say that they are strong substitutes, a lot of people would disagree. And so that is why we classify these two goods as weak substitutes, and their value is less than 1. The other type of substitutes are strong substitutes. So let's say Coke and Pepsi, we have Coke, we have Pepsi. And so since a lot of people don't really realize that there's a difference in their taste, um, they don't really have any preference, or even if there is a preference, the preference isn't really that strong, and so they would consume either of the two, Coke or Pepsi. And so we classify these goods as strong substitutes. Then C represents a value of XCD which is less than 1, and it's negative at the same time. So negative values represents complements. Complements are basically goods which are consumed when one good is consumed more. So let's say if we have good A and B, or let's take an example, a car and fuel. Car and fuel. So in this case, what's happening is, let's say if you buy a car, then obviously you will buy more and more fuel. And so if the demand for one of them goes up, the demand for the other goes up as well. Just like that, let's say if the price of fuel goes up, then the demand for cars will go down. And so that's why they have this positive relationship. They have this negative relationship. And so because of that, they're known as complements, and the value of XCD is negative. In the case of weak complements, I think we can take any example. Let's just stay with good A and B. So we have good A and we have good B. So let's say if people were to consume good A over here, then in that case they do consume good B, but not necessarily, since they're weak complements. Unlike in this case, when people obviously buy cars, so they buy fuel as well. Now, if there was a change in price of B, right? Let's say the price of B goes up, the demand for A will go down, since people consume both of these goods in tandem. But at the same time, since they aren't really consumed necessarily together, right? As we describe them as weak complements, the demand won't really go down by a lot, and so the change in demand will be low. as compared to this case where we have a negative value which is greater than 1, which represents strong complements. So let's just take this example here. Just going to copy and paste this one. So car and fuel. And so if you were to take the example of car and fuel, if you buy a car, obviously you will buy more fuel. There is no other way to this, since, well, why would you buy a car if you don't want to drive the car? But in most cases, they are strong complements. And so let's say the price of fuel goes up by a lot, right? Then the demand for cars, or QD for cars, will go down by a lot as well, as compared to in the first case where the demand went down by a lower value. And so these are the 4 different categories and then the 4 different types of values we have within XCD. So that's pretty much it from this video.